Hello, welcome to Amay Kadam's channel. In this video we will see the actual designing of low pass composite filter for a given specification. So just before proceeding for the designing numerical, I will just revise the formula that we have derived. So we have low pass filter and high pass filter, and if we know R0 and omega C, one can derive this formula. I explained this thing in the last lecture. And then composite filter consists of 4 blocks: bisected pi matching network, where m is equal to 0.6 will be used at the input side and its mirror image will be used at the output side. The intermediate 2 blocks are constant k T section network and m derived section. So this we have seen in the last lecture in detail. Now we'll actually start solving the numerical. So the problem goes like this: design a low pass composite filter with cutoff frequency 2 MHz, impedance 75 ohm, and place the infinite attenuation pole at 2.05 MHz. So we'll mention the data related to this one. So this is nothing but FC. FC is equal to 2 MHz. This is F infinity. It's not, just be careful, these are not omega, they are nothing but f infinity is 2.05 MHz, and you have R0 is equal to 75 ohm. So first we'll design the constant k T section network. So you have L by 2 over here in the horizontal arm and C over here. So L can be calculated as 2 R0 by omega C, and C is 2 omega C by R0. So it results into, L results into 11.94 microhenry. You can check this calculation, and C turns out to be 2.122 nanofarad. Be careful about the calculation. Omega C is nothing but 2 pi FC. So here you will have 2 pi FC, and again here over here you will have 2 pi FC. So we have calculated the values of L and C, but here the component value is L by 2. So we will divide this by 2 and it will result into 5.97 microhenry. The value of the C turns out to be 2.122 nanofarad. Okay, so after constant k T section derived, we will proceed for the m derived section. So for m derived section, these are the components and one has to calculate m. So here they have mentioned, I have mentioned the formula 1 minus omega C by omega infinity whole square. Here one can write the formula as 1 minus fc by f infinity the whole square, because the 2 pi will get cancelled. And after substituting fc as 2 and f infinity as 2.05, the m value turns out to be 0.2195. So here we have to put m is equal to 0.2195 and we have to calculate the component values. We'll use the same L over here and C over here, this C 2.122. So ml by 2 turns out to be 1.310 microhenry. This capacitor M turns out to be 465.8 picofarad, and this component inductor turns out to be 12.94 microhenry. So for designing m derived T section, one has to calculate m from fc and f infinity. Since this is a low pass filter, the formula of m is 1 minus fc by f infinity the whole square, whereas that in high pass filter the formula of m becomes 1 minus f infinity by fc the whole square. Now the last part of the composite filter, that is bisected pi matching network. So as I mentioned earlier in the last lecture, one has to copy this section as it is over here, and this 4 you have to split over here. So this 4 will go as divided by 2, and here it will be 2. But for bisected pi matching network, m has to be 0.6. Okay, so ml by 2 turns out to be 3.582 microhenry, while mc by 2 turns out to be, after substituting c is equal to 2.122 nanofarad, m as 0.6, you will have 636.5 picofarad, and this component value turns out to be 6.368 microhenry. So we have calculated all the components over here. Now we have to basically design this composite filter by cascading these elements. So at the input side, first you will have bisected pi matching section, then you will have constant K section, then M derived section, and then at the output side you will have mirror image of this one. So the circuit will look like this. So this bisected pi matching network will come over here. So we'll copy these values. So these values are 0.582 microhenry, 6.368 microhenry, this inductor I am showing over here, and this capacitor to be 636.5 picofarad. So output of the matching section is given to constant K section, T section network. So here you will have 5.97 microhenry, while the capacitor value turns out to be 2.122 nanofarad. Now the M derived section, so ml by 2 turns out to be 1.310 microhenry, and these values and now we will have a mirror image of this matching section over here to provide the output impedance nearly equal to R0. R0 is nothing but the nominal impedance. So that completes the design of low pass composite filter for a given specification. In the next lecture we will see one more numerical on low pass composite filter and one numerical on high pass composite filter design. If you have any query, you can mail it to me at this email id kadam.ameya@gmail.com. Thank you.